Okay, so we're getting ready to wrap up 8.1, the second half now. You have all the basic information, exponential growth, exponential decay formulas. These problems are the same types of problems using exponential decay, exponential growth, but the algebra is just a little different. Different pieces are given to you, so it's not as straightforward. Here's your start time, here's your rate, here's your time. Find out what the answer is. You have to do a little bit of solving, and also there's one trick on your calculator you're gonna have to do. An industrial machine is worked all day, every day. It has a decay factor of 0.75. It is currently 6 years old and is worth $7,500. How much was the original value? So think about what they're asking here. Okay? They're asking for the original, the starting amount. So we're looking for A in this case. That $7,500 is how much it's worth now. That's our Y. So that's two important pieces there. The other important thing I want to pick out, we're looking at decay factor. Okay? So it's not giving us a rate this time. So when we're looking at our formula, y equals a, 1 minus r to the t power, they give us a lot of information and we're looking for a. So they're telling us our y is 7,500. The a is what we're looking for. The factor this time, there's not 1 minus 0.75. The factor is 0.75, so it's just 0.75 in the parentheses. It's very important you read these carefully. I even bolded it just so we can see it there. And they said currently 6 years old, so our time is 6. Okay? Now there's a couple different ways you plug this in, so you will be given a little wiggle room. If you do the calculation, 0.75 to the 6th power, A times 0.178, and then do your division, that's going to be a little different than if you just take 7,500 divided by 0.75 to the 6. Okay, your answer might be a little different, so I am going to give you a little wiggle room on here. Okay, so you should be somewhere around, I have $42,134.83. Now I usually do that work there. Do the 0.75 to the 6th power and then divide to that 0.178. You're more welcome to do it like this. Like I said, you're not have to show your work on these questions, so you are not be given a little wiggle room depending on what your final answer is. Okay, so important things here. Look what they're asking for, look what's given to you, and pay attention if it says factor or rate. There is a difference. You're trying to invest in real estate. You find a nice house in a growing area that is worth $154,000. The value of the house is increasing at a rate of 1.1% every year. About how many years will it take for the house to be worth over $200,000? So we're looking for it to end up at $200,000. So that's kind of what our Y, that's what we're looking for. Our A is our starting amount. Our rate here is 1.1%, and the question we're looking for, about how many years, we're looking for our time. So this time, if you would set this up, y equals 154,000, 1 plus, it is increasing by that rate, 1 plus 0.011 to the t power. So we want to know, what does that t have to be until that y, to make that y equal 200,000. So we haven't gone over how to solve this equation yet. Later on in the chapter we will, and on the test you're going to be given your choice of how to solve for this. Right now though, I want you to use your calculator function. Use the table function. Plug this equation into y1, and then go to your table and just start scrolling until you get to 200,000. Okay, we've used the table function in chapter 6, so you should be familiar with it. We use it in chapter 3. Just start scrolling down and tell me, what's the first year we're going to be over 200,000? Okay, you should be able to plug that in, and you should have, I have it at about 24 years. That's the first year it's over the 200,000 mark. Okay, so right now we're using our calculator, the table function, to answer these questions if you're looking for the exponent. And in this case, we're looking for time. So that's how we go about that. The number of students who graduate from Cornea High is dropping each year. The township has decided to close the high school for the year after less than 150 students graduate in a year. If 235 kids graduate this year, but that number drops 4.6% each year, how many years will it be for the number to be less than 150? Okay, so again, let's think about what they give us. Here's our rate. Right now, 235 kids are graduating. Okay? And we're looking for the time. Again, how many years? That's what we're looking for. That 150, that's what we want to see. What's T have to be for that number to be under 150? How many students are graduating? So this time when you're setting this up, we have Y equals, start at 235. Now students are decreasing, so it's going to be 1 minus, and it's at 0.46, so it's going to be, 4.6%, so 0.046 to the T. And we're going to do this the same way. Plug that into Y1, go to your table, and just start scrolling. And I want to know the first year, we're under 150 students. Okay, I have it as 10 years is going to be when we're under 150 students. That's when that high school would be closed, and we'd move on from there. Okay, so there's using your calculator. Find that exponent that you're missing, or at least estimate what the exponent is. Again, later on, we're going to find more ways of solving those. Okay. Here's the problem. Tell me, is it growth or decay? What the growth and decay factor is, and what is the growth and decay rate. Okay? All this is going to be explained by what's inside the parentheses, the B. Okay? Think about what the formulas are. Y equals A 1 plus R to the T power. Y equals A 1 minus R to the T power. Okay, so for number one, is it growth or decay? Well, think about it. It's either adding to 1 or subtracting from 1. If you're adding something to 1, we know R has to be positive. Okay, you can't lose a negative percentage, so it's going to have to be positive. If you're adding a positive number to 1, it's going to be greater than 1. If you're taking a positive value from 1, it's going to be less than 1. So determining if it's less than or greater than 1 will tell us if it's growth or decay. 0.47, that's less than 1, so number 1, this is going to be a decay function. Okay, number 2, what's the growth/decay rate? Well, we know it's decay, so it's decay factor. We know it's decay, so we're looking at the decay factor, and that's whatever's in the parenthesis. Okay, 0.47 is what's in the parenthesis. That's considered our factor. Now, the rate you need to think about. We said it was decay, 1 minus R. So 1 minus R equals 0.47. You need to think about what R is. What minus 1 will give us the 0.47? You just solve that equation. Subtract your 1, divide by negative 1. You should get R equals 0.53. Now I'm going to ask you, write your rate in percent form. So 0.53 would be 53%. Okay, so there's an example. You're looking at B to answer these questions. Greater than 1, it would be growth. Less than 1 is decay. This was less than 1, so we have decay. The factor is whatever's in the parenthesis. And the rate, you need to figure out what is R. Now this is not be different if it's growth. It would be 1 plus R equals whatever the factor is. So you do need to make sure you're paying attention. Is it plus or minus R? And make sure your rate is in a percent form. Here's another example here. So again, we're looking at what's inside the parentheses. So answering these same questions. 1.35. It's greater than 1, so this time it's growth. The growth factor is whatever's inside the parentheses. So there's 1.34. Now we have 1 plus R equals 1.34. So again, we have to think about what that R would be. So again, just solving this. Subtract 1 from both sides, and R equals 0.34. So that would be 34%. Okay, so there was an example of growth. We had an example of decay. be able to look at the equation and answer these 3 questions. And the last thing is looking at a graph. Okay? We're looking at a graph, and now we want to put together the function for this. So if we're looking at this, you should be able to look at the graph, starts up high and goes down, and determine, is it growth or is it decay? This one starts up high, is going down, so we know it's decay. You need to identify your A and your R. So you're going to need to pick out what our A is and what our R is. The A should be fairly easy. That's our starting point. Okay? Up here, I know you're estimating, it might not be the best graphs all the time, but that looks like it's starting at 100. So y equals 100, 1 minus something to the t power. Okay, now this is the model. We want that t to be a variable because now we're not going to be able to determine, okay, what is the value at t equals this, t equals this. Now to get that rate, what you need to think about is the difference divided by the start. So I want to know what is the difference from the first point to the second point. What is that difference divided by the starting point? That will give you your R. No matter if it's growth or decay, that will give you our amount. So if we look at the first 2 points, it starts at 100, drops down to 50. So 100 minus 50 equals 50. That is our difference. Okay? The difference between the two, and that means our difference divided by our starting amount, so whatever's in our parentheses here is 100, and that gives us 0.5. You probably could have seen this just by looking, okay, what's half of 100? We get 50, so we know it's 50%. But here's the math to get that value. We have 0.5 would be our rate. This is the model I'd be looking for. Okay, so there's one example. Let's do another example, but again, difference divided by start is the important part to get our R. Okay. Let's look at our next graph. Okay, so height of a swinging pendulum, and here it has points started off for us here. Okay, so if I'm looking at this, okay, again, it's starting up high, going down, so we know it's decay. Looks like it's starting at 6, so right there's our starting amount. Y equals 6, 1 minus something to the t power. And now, they gave us some points. It really doesn't matter what 2 points, just pick 2 consecutive points, and that's where you can go from your starting, the difference here, so you can find the difference between the two. So if we look at our first 2 points, they're giving us 3.6 and 2.16. Okay, so if we do that math, the difference between the two, 3.6 minus 2.16, and that should give us 1.44. And there's the difference. Just make sure now that your starting amount, these are the 2 points we looked at, this is the one we have to divide by. 1.44 divided by, we start at 3.6, and that should give us a 0.4 for our rate. Okay, so it's still difference by start. We just didn't use the very beginning here. We used 2 points, but they're just consecutive points that we're looking at, and 0.4 is our rate. Okay, difference divided by start is going to give us our rate. Okay, and make sure they are consecutive points. They don't have to be the very first point. Okay, I use these just to show you. As long as they're consecutive points, you should get the same rate there. So you should be okay. And even if you don't, let's use the other points. Start at 6 and go into 3.6. Well, 6 minus 3.6 should be 2.4. 2.4 divided by 6. If you do that, that should give you the 0.4 again. Okay, so it works out the same way, so we should be okay doing that. Okay, picking any 2 consecutive points, difference divided by start. Okay, so there's the end of 8.1 exponential functions.